Atom is the smallest particle of an element that retains the element properties. In the center of an atom there is the nucleus that is made of smaller particles, which are the neutrons and protons. The protons are positively charged and the neutrons, which have approximately similar mass to the protons, are neutral. The force that keeps the neutrons and protons together in the nucleus is the strong force. There are also particles called electrons, which are smaller than the protons and neutrons. These electrons rotate around the nucleus and are negatively charged. The total negative charge of electrons is equal to the total positive charge of protons, making a neutral atom.
Democritus is an ancient Greek philosopher who was the first to propose the idea of an atom. He said that all matter consists of atoms which are indivisible and solid. He also stated that all atoms differ in size, shape, and mass.
Dalton is an English scientist who proposed the atomic theory, which consists of 4 postulates. The first postulate states that all matter is composed of atoms which are indivisible and indestructible. Yet the point that atoms are indivisible was falsified, as later on the subatomic particles such as protons, neutrons, and electrons were discovered. Also, the part that atoms are indestructible was later on falsified due to the fact that nuclear fission takes place now in atomic bombs and nuclear reactors. The second postulate states that all atoms of a given element have the same mass that distinguishes them from other atoms. Yet also this postulate turned out to be incorrect due to the presence of isotopes, which are atoms that have different numbers of neutrons. The third postulate states that atoms combine to form compounds in simple whole number ratios, which has been further supported to be correct. Finally, the fourth postulate states that an atom of one element cannot change to be an atom of another element. So chemical reactions only involve the rearrangement of atoms together, which has been further supported to be correct. So simply, atoms can neither be destroyed nor created.
Thomson is a British scientist who was the first to discover the electrons by the cathode rays method. The cathode rays were deflected by a magnet in the vacuum tube, and this was an evidence that there are particles much smaller than the atoms that are negatively charged. This made him think about the atom structure, that he called the tumbling, where the atoms were made of positively charged sphere with electrons embedded in it.
Rutherford is a British scientist who conducted the gold foil experiment that led to the discovery of the nucleus, which helped him to form the modern atomic structure. In the gold foil experiment, he shot beams of alpha particles that hit a thin gold foil, and around the gold foil was a screen that detected the alpha particles. He observed that some of these particles passed undeflected, while others deflected with small angles, and the shocking surprise was that some of these particles were reflected back to the source. Using these results, he speculated that there is a positive dense center called the nucleus. His discovery of the nucleus aided him in his formation of the modern atomic model.
Niels Bohr is a physicist who contributed to the understanding of atomic structures and quantum theory, using Max Planck's idea that energy comes in specific packets called quanta. Bohr made his model that is referred to as the planetary model. According to this model, the electrons are found at fixed energy levels and also at fixed distances from the nucleus. The farther we move away from the nucleus, the higher the energy. In Bohr's model, electrons can jump from one energy level to another, but can't be found between them.
In 1924, Louis de Broglie, a French physicist, proposed that matter has dual characteristics just like radiation. His concept about the dual nature of matter was based on his observation that the whole universe is composed of matter and electromagnetic radiation. Since both are forms of energy, so can be transformed into each other. According to the de Broglie concept of matter waves, the matter has dual nature. It means when the matter is moving, it shows the wave properties like interference and diffraction. When it is in state of rest, it shows particle properties. Thus, the matter has dual nature. The waves associated with moving particles are matter waves or de Broglie waves.
Heisenberg was a German scientist and one of the key pioneers of quantum mechanics. Heisenberg came up with a competing theory called matrix mechanics. This was so mathematically complex that hardly anyone really understood it, including Heisenberg himself, who said, "I don't even know what a matrix is." Then, building on Broglie's ideas that electron is a particle that can be described in terms of waves, he formulated the uncertainty principle, which asserts that we can know the path of an electron as it moves through space, or we can know where it is at a given instant, but we cannot know both.
Schrödinger is an Austrian physicist who formulated the wave equation and proposed a new interpretation of the wave function. Building on de Broglie's ideas, he developed his wave mechanics equation by referring to the universal wave aspect not to ordinary physical space-time, but rather to a different and more abstract space. His wave equation plays the role of Newton's laws and conservation of energy, and predicts the future behavior of an atom. When solving the equation, we can predict the probability of where the particles will be at a given instant of time. This function can be used to calculate the possibility of finding any electron in an atom in a specific region around the nucleus.
Albert Einstein, a German theoretical physicist, was able to prove the existence of the atom through studying the Brownian motion. The Brownian motion, named after Robert Brown, is the random motion of particles suspended in a fluid due to their collision with the quick atoms or molecules in the fluid. Einstein then explained the precise detail of how the motion that Brown had observed was a result of the pollens being moved by individual water molecules. Then he derived how big atoms should be based on how the particles move. This explanation of Brownian motion served as definitive confirmation that atoms and molecules actually exist. Einstein then explained why light is a particle. He noticed the light coming from a source like a bulb filament that actually had the energy distribution as a gas. That was surprising at this time. Einstein then proposed that these light quanta were in fact real particles. This was supported by the photoelectric experiments later.
Dalton, Thomson, Rutherford and Bohr, Schrödinger and Heisenberg and many, many more used their brains to venture in the realm of inner space and found the world of the atom was a weird and wondrous place. Dalton did experiments and said, "I think it's clear atoms are tiny indestructible spheres." Thomson worked with cathode rays, said, "I disagree. A plum pudding model makes much more sense to me." A new chapter in atomic theory started to unfold when Rutherford played around with atoms made of gold. When a few of his alpha particles came bouncing back, he hypothesized the nucleus had knocked them off the track. Dalton, Thomson, Rutherford and Bohr, Schrödinger and Heisenberg, and many, many more used their brains to venture in the realm of inner space and found the world of the atom was a weird and wondrous place. Bohr saw spectral lines for hydrogen and said, "It seems to me electrons move in orbits with specific energies." Heisenberg said, "Forget it, there's no way to know the orbit or a path where the electron's gonna go." Schrödinger used lots and lots of fancy mathematics, made a model of the atom based on quantum mechanics. It has orbitals, and those are based on probability. The atom is a fuzzy blob of pure uncertainty.